Hello and welcome to another one of my How to Bias video series, and this time we're going to be biasing the Fender Pro Junior. Not a very easy amp to bias. It requires the adjustment of one fixed resistor on the board, and Fender have derived the negative bias voltage in a very weird way on this amp. I don't like it at all, but anyway, it is possible to adjust the bias and I'll show you how. So let's dive straight in and get on with it. Okay, the amp is on. I've got the bias meter connected, and the correct bias for 330 volts on an EL84 is 25 milliamps. So this is a little bit on the hot side. I think I might just bring that down a bit. At the moment I have absolutely no idea how to do that, so I'm going to need to remind myself. I think I've written a bias manual for this particular amplifier, so I will go and grab my bias manual and see what I'm supposed to do, and I think that will be interesting for you as well. It's going up to 30 milliamps, so that is a bit too hot. If it was a milliamp or two I wouldn't mind, but it's 5 milliamps hot. So let me go and grab the bias manual and we'll see. We'll have to change a resistor on the board somehow. It doesn't mean taking the board out. And then we'll bring that back down to 25 milliamps. Okay, I've just had a look at the schematic. I didn't write a bias manual for this amp. I don't think I've biased one before. And the bad news is they've got a kind of weird ass way of getting the negative minus 10 volts bias voltage here. And they do it by this, to my view, rather kind of shonky system of taking a sniff of the HT. Don't forget this is like 130 volts AC here, and taking it through this capacitor and just allowing enough of it to go through to rectify and smooth using these capacitors here to get the minus 10 volts. It's never a very satisfactory way, but of course it saves them having a separate winding for the HT, which saves £1.50 on the transformer cost, which, you know, well, I'll say no more. Now the only way to change the bias on this is to change the value of this resistor here, this R29. Changing that does a certain amount, but it's not very much, and changing this does nothing. So the bad news for us is decreasing the value of R29 increases the bias current. That's not surprising because it means we get less negative voltage here. If you like, more of it goes to ground. So less negative bias voltage, this goes down to say minus 9 volts or something, means more bias current through the tube. So we need to increase the value of R29 from 15k. So what I'm going to do is I don't want to take the board out again, and I've found a way to do it without taking the board out. So there's R29 there. It's across this capacitor here, C13. So that point's connected to there, that point's connected to there. Where are we on the schematic? R29, look, it's across this 10 microfarad capacitor. So I'm just going to put a 22k across that capacitor and just chop one leg of that out. And that will be perfectly satisfactory. So why don't I do that now and see how close we get with 22k, or whether we've kind of overcooked it. Okay, well the answer is that we've overcooked it. I cheated a little bit and put my resistance decade box on the job. Let me zoom out a bit. So I've just dialed in 22k and we've got 15 milliamps. So 22k is not enough. So let's go down to let me see, what was it originally? 15k. Let's try 18k then. 18k. Okay, yeah, that has come down a bit. It was 30 if you remember. So 19k. Oh, it's quite sensitive. We're after about 25 milliamps, so you know what, I'm tempted. 27, 26.9. I'm happy with that actually. 27 milliamps, 18k. I think I'll put an 18k in there and call that job done. Right, there you go. You can see I've clipped R29 and just bent it out the way. and I've tacked an 18K across C13, which of course is exactly where R29 went. It was just easier to solder onto C13. Now purists watching this are going to be texting me and emailing me saying, you can't do that, you should take the board out, all that kind of stuff. I promise you that that joint there will be good in 30 years from now. There's nothing going to go wrong with that. And there's no free lunches in maintenance. To do that properly, in inverted commas, I have to take the board out again. Okay, so first of all, that's another £30 on the bill for the customer, and we're stressing these ribbon cables here, so possibly building up some problem in the future. So you create a problem here to save a problem there. You know, you have to take a view on these things, and as I say, that is a perfectly good repair. Nothing is going to go wrong with that solder joint, I can assure you. That'll be good. So I'm happy with that repair. We've got exactly the right, or very close to the correct bias current, and we're good to go. Okay, well, we managed to bias the amp without too much drama. It's easier if you need a bit more bias current, because you can just tack a resistor in parallel across the existing resistor. But in our case, we needed to reduce the bias current, and that meant increasing the value of that resistor. So we had to effectively swap the resistor out for a higher value. And that resistor is very sensitive. Just 1k here or there and you've got 3 or 4 volts difference in the bias current. So not a great way of designing an amp really in terms of changing the bias, but anyway, there you go. They probably saved themselves £1.20 by doing it that way, and that's what it's all about, I guess. So thanks for watching. I hope you're able to bias your own amp, and I'll catch you on the next video.